I want to introduce you to rational expressions, which look complicated, but they're actually not that difficult to deal with. A rational expression by definition, like this example, is just a polynomial over a polynomial. So it's like a fraction made up of polynomials. Okay, and so since they are like fractions, the arithmetic operates just like you do with fractions, and we'll show that. First of all, I want to point out something that we call simplifying rational expressions. So you would generally not deal with something like this, 3/6, right? You'd want to reduce that down to say, well, that's the same as 1/2. Why talk about 3/6 when you can talk about 1/2? Okay, so with this rational expression I have here, x squared plus 3x minus 18 over x squared minus 4x plus 3, it's possible that I'm looking at a 3/6 situation. Can I reduce it down to something that's more like a 1/2 situation? And the way you'd want to do that is through factoring. Can you factor and find common terms in the numerator and in the denominator? Let's take a look. Okay, so if I try to factor this numerator, I need two things that multiply to give me negative 18 and add to give me positive 3. I think that would be a negative 6 and a positive 3. That's not right. It's actually a positive 6 and a negative 3. Multiply to give me negative 18, add to give me positive 3. And the denominator, okay, I need two things to multiply to give me 3, add to give me negative 4. How about negative 3 and negative 1? Multiply to give me positive 3, add to give me negative 4. Okay, so now I have factored the numerator and the denominator, and you can notice that my numerator and my denominator have a common term. So that common term is x minus 3, so I can cancel those out like that. And that's how we simplify a rational expression. And this is just like the way we simplify fractions. I'm going to show you a couple more examples, and I hope this makes sense. Alright, so I have three more examples I want to show on how to simplify rational expressions. And really, it comes down to factoring. So for example, in A here, I have x squared minus 4x plus 4 all over x squared minus 4. What I want to do now is just factor to see what kind of parts I have in this thing. So for example, the numerator, I need two things that multiply to give me 4 and add to give me negative 4. So I can see that would be minus a negative 2 and a negative 2. And in the denominator, x squared minus 4, remember, is the difference of squares. So that's going to factor, as x minus 2 times x plus 2. Okay, and so from there, now that I have a common factor of x minus 2 in the numerator and the denominator, I can cancel it out. Okay, so I should also mention, well, first of all, the simplified version of this is x minus 2 over x plus 2. And I should also mention the things that x cannot be. Okay, so we can definitely say x is not negative 2 because of what we have in the denominator here. But also, I need to remember that at the beginning, which is what this is referring to, I also couldn't be positive 2 because of the way it factored here. Okay, so when you factor it, whatever you have in the denominator, regardless if it cancels out or not, you still need to make that restriction that x cannot be that thing. So here's my answer. X minus 2 over x plus 2, and x is not allowed to be negative 2 or positive 2. Okay, now looking at B, we see that the numerator is 8x cubed minus 27. That's going to be a difference of cubes situation. So if you remember the formula for the difference of cubes, it's something you may need to remember. It's a minus b times a squared plus ab plus b squared. Okay, so in this situation, a is going to be 2x for a, and b is going to be 3. So then based off my formula, I can see that this thing factors in as 2x minus 3 times a squared, which would be 4x squared, plus ab, which is 6x, plus b squared, which is 9, all over 2x minus 3. And so then I can see then the 2x minus 3's cancel out. And what I'm left with then is a 4x squared plus 6x plus 9 all over 1. So we'll just write it like that, like a polynomial. And I do need to mention my restriction. So what is my restriction? Well, you might have to do some scratch work, but you think, okay, let me think. 2x minus 3 cannot be 0. So that means 2x cannot be 3. So x cannot be 3 halves. So there's my restriction as well. So here x cannot be 3 over 2. And there's my solution. Okay, now in part C, we have something again very similar. We have x to the fourth minus x cubed over x squared minus 3x plus 2. And I'm going to factor everything I can. So in the numerator, I can take out an x cubed out of everything. And remember, your first strategy for factoring should always be to try to take out the greatest common factor. So take out the x cubed, which leaves me with the x minus 1. In the denominator, I need to think of two things and multiply to give me 2 and add to give me negative 3. How about x minus 1 and x minus 2? I think that works. And so now we can see the x minus 1s are my common factor that cancel out. And I'm left with an x cubed divided by x minus 2. And we can see that in the restrictions from this step here, x can't be 1 and cannot be 2. So there's my solution. To end our discussion on simplifying rational expressions, I do want to offer one warning. This is a mistake I see in students a lot, and I wanted just to warn you about it so you can avoid it. We have something like this, x plus 3 over x. And I see students a lot of times want to cancel out these x's and just say that's the same thing as 1 plus 3 over 1, which in this case would be 4. This is a mistake. You can't cancel out the x's like this. Just like, here's an example. If I said 3 is the same thing as 6 over 2, okay? And 6 is the same thing as 2 plus 4, and I cancel out 2's there. Then I end up with 1 plus 4, which equals 5, and I get 3 equals 5. We know that doesn't make any sense, so where was the mistake? The mistake was right here. I can only cancel something out if I can take that factor out of all my terms. So since I can't take an x out of the 3, I cannot cancel out x's. The only time I could do that again is if I can take it out of all terms. So if I had something like this, x squared plus 5x over x squared minus 2x, now notice all four terms in this expression have a common factor, x. In this case, I could factor out one x out of everything and end up with x plus 5 over x minus 2. I hope this makes sense. Simplifying rational expressions is a very useful thing to know how to do. If you have any questions on it, please let me know. I'd be glad to help. And thank you for watching.